Hey guys, welcome to Not So Nerdy channel. Today we are going to understand what a dequeue is because our next question of sliding window is using the concept dequeue. So let's try to understand what is a dequeue. It's a short for double-ended queue. It's a data structure in Python that is similar to a list but fast and efficient for addition and removal of items from both ends of the queue. So you have a dequeue here and you can access the elements from both the sides. You can push and pop the elements. So that's a basic idea of dequeue. Some important things that you should know. It can be created using the collections module, which is included with Python. So from collections, import dequeue, and you put it in a variable, say D. D is your dequeue. Now here you have made an empty dequeue, and it can be used like lists to add or remove elements from the end. So first you d.append 1. So you append 1, you add it from the right hand side. Then you do d.append left 2. So you are appending the second element from the left hand side. And for that you are using the syntax append left. And then you pop d.pop. So for popping, again you'll remove from the right side. And if you want to remove from the left hand side, you use d.pop left. So here you initialized an empty dequeue. Then you added 1 from the right side. Then you added 2 from the left side. Then you removed 1. You popped 1 from the right side. Then you used pop left to remove from the left side. Okay. So dequeue can also be indexed like lists. So suppose you want to print the first element, you use print d0. If you want to print the second, the last element, you use print d minus 1. So here's an example. Suppose you have dequeue 1, 2, 3, 4, 5. These are the elements. So if you want to print the first element, you'll use d0 and its output will be 1. Then you'll print the last element, you'll do d minus 1. So you are accessing it from the right hand side. So last element on the right side. Now dequeue can be used to implement queues. For queues, you can use dequeue where elements are added to one end and removed from the other. So it's first in, first out, right? FIFO. So you are using dequeue for it. So queue is equal to dequeue. Queue dot append 1. You are adding 1. Then you are adding 2. You are appending 2. And then you are popping from the left side. So queue dot pop left, removing from the front side and the back side. So you are adding 1, you are adding 2, and then you're removing 1 first. Then dequeue can also be used for implementing stacks where elements are added and removed from the same end. So it's like last in, first out. So you have a stack s equal to dequeue. So s dot append 1, you are adding 1, then you are appending 2, and then you're popping. So you're popping 2 first. You're not popping 1 because you're using s.pop. And dequeues can have a maximum length specified when the dequeue is created. So suppose you have defined that, okay, this queue should have only 3 as your max length. Okay, then you add your 1, 2, 3, and now you add the 4th element. So it's not allowed, right? So what will you do? It will automatically remove 1 from the left hand side since dequeue is at max length. Okay. So dequeue can also be reversed in place. So suppose you have d equal to dequeue 1 to 3, you do d dot reverse and you print your d and you get your output as dequeue 3 to 1. Dequeues can be converted to list using the list function. So d is equal to dequeue 1 to 3. You do the list. You use the list function, and then it prints your list 1 to 3. Okay. Time complexity. So here are the time complexities of the various operations that we saw. So for accessing an element at a specific index, it's using O1 time. For adding or removing an element from both the ends, like if you want to remove from the front or the back, it's gonna be O1. For adding or removing an element from the middle, anywhere from the middle, the worst case, and we'll take the worst case scenario, it's gonna be ON. Checking if an element is in the dequeue, ON, and reversing the dequeue, ON. And if the dequeue needs to be resized, then the time complexity of the operation will be ON, where N is the number of elements in the dequeue. So that's a brief summary. I'll upload this PPT in I'll share the Canva link to you and you can access it. And yeah, feel free to ask your doubts to me. Thank you.